Hi everyone, in this video I'm going to go through how we can use the law of cosines, which should be a formula that you're somewhat familiar with when dealing with non-right triangles. So I'm going to show you how I can apply both the law of cosines and Heron's formula. So this is the law of the cosines. Now one good thing about this is that you will not have to memorize this. It's not something that I feel like is necessary to memorize, but you do need to know how each part of it works. So what's really important is that this big C and this little c refer to the angle and its corresponding side. You may kind of see Pythagorean theorem in here, and if you remember, C was the hypotenuse. This is more like the side that corresponds to the angle. Just like the hypotenuse corresponded to your 90-degree angle in a right triangle, this is how we want to actually think about that C. A and B do not matter which one you choose as A and B, but just identifying which one is the correct C is important. So let's see how this will work. So in a triangle like this, I cannot use the law of sines because I do not have a single matching angle or side. So I am forced to use the law of cosines. Now you may say that C is right here, but realistically, again, what I care about is the angles and sides that I'm looking for. I have angle A and I want this little a. So technically in my formula, this is going to be C. Now if you want to, cross it out and make that little c, make this big C, and make this my angle A, which makes this little a and little b. You are more than welcome to do that, just so that you have that clarity, but that's really all we're doing. Okay, so the formula being C squared equals A squared plus B squared minus 2AB cosine of C. A and B are 15 and 17 respectively, so 15 squared plus 17 squared minus 2 times 15 times 17 times the cosine of 30. Now when I go to do that, I do not recommend you put this all into your calculator at one time, so I like to do it in chunks. This is 514. The negative 2 times 15 times 17 times the cosine of 30 gets me negative 441.7. We'll round it there. So then when I do 514 minus 441.7, I end up with C squared equals 72.3. And as usual, we take the square root to get my final answer here. And so C in this case would be 8.5. So that's really it for the law of cosines. What's kind of more important to understand is just take your time with the formula. So this is my angle C, which means 19 is my little c, A and B. So when I'm looking for the angle, this tends to be where most people will make this common mistake. So plug into the formula 19 squared equals 8 squared plus 15 squared minus 2 times 8 times 15 cosine of C. Now, again, I don't have C, but what I can do is I can actually just plug all these pieces in. Again, a few small steps at a time make this a really easy problem. Doing too many at a time will lead to incorrect answers. 289, 2 times 8 times 15 gets me minus 240 cosine of C. Now, the common mistake that I see is that people want to combine these two numbers, and that's not possible. This cosine of C really acts as its own variable, just like x. So you wouldn't want to combine something like 2 plus 4x just because the numbers are in front of it, right? This would be left as is. But what I can do is I can subtract the 289 from the 361. That gets me 72 equals negative 240 cosine of C. Divide 72 by the negative 240. I get cosine of C equals negative 0.3. And so now I just do the cosine inverse of that 0.3. And so that this angle has to be 107.5 degrees roughly. Okay, and then in our word problem here, so let's say we've got two planes flying out of the airport at the same time. So here's my little airport. One flies 500 miles per hour for 2 hours, so that's 1,000 miles here. The other one flies due southeast, which actually means exactly 45 degrees in the southeast at 300 miles per hour. That's 600 here. And we want to know what is the distance that they are separating at that 2 hour. So again, I need a matching angle side pairing in order to get law of sines. So what I need to do is I need to use little c here to determine what my big C is. Now, we know that this angle right here is 90 degrees and south due east means exactly in the middle. So both of these are 45 and 45. So if I redraw my triangle, we have 1,000 here, 600 here, 135 degrees here, and we're looking for our C. So in my formula, I'm going to use C squared equals 1,000 squared plus 600 squared minus 2 times 1,000 times 600 cosine of 135. It's going to be a big number, by the way. So I'm going to do this part first. Let's rewrite this so I have some space. So the 1,000 squared plus the 600 squared is 1,360,000 plus, now let me use a different color. So I'm going to do the minus 2 times 1,000 times 600 times cosine of 135. Now it's going to get a little bit weird because what it's going to do is actually going to be an addition. And the reason why that happens is because cosine of 135 is actually a negative value. So what that will mean is that we basically add them together. So then I add, and I get C squared equals 2,208,528.1. And now taking the square root of that number gets me 1,486.1 roughly feet apart. Okay, so that was everything with the law of cosines. Now just a real quick note on Heron's formula. Again, this is the formula. Just like area of a triangle is 1/2 base times height, Heron's formula is what we call the semi-perimeter. So if you just remember what perimeter is, it's just the sides of a triangle added up. So the semi-perimeter is half a perimeter, which you can see right here in the formula. That's A plus B plus C, the sides of a triangle. Now to find the formula for the area, it's this equation here. So area is the square root of the semi-perimeter times the difference between the semi-perimeter of the first, second, and third side. So we're going to use that formula on our next triangle here. So if I have a triangle with these 3 side lengths, the perimeter is 23 by adding it, which means my semi-perimeter is half of that. So to find the area, we just use the formula. So semi-perimeter is 11.5, and then 11.5 minus 11, 11.5 minus 5, and 11.5 minus 7. So my area is the square root of 11.5 times 0.5 times 6.5 and 4.5. So I would just put this into my calculator. And that's really it for Heron's law. You just need to find the semi-perimeter and use that formula about the differences. So the square root of 168.1875 gets me a area of approximately 13 kilometers squared. All right, I hope that was helpful. And yeah, see you in the next one.